Yes. Do I have what?
A pen.
My desk. Check what's there. Okay, we are going to find the roots, which is the same as solutions of a polynomial algebraically. So the grouping that we did before, synthetic that we did before, it's going to be used here. Quadratic formula, and then there's a new one, the remainder theorem. Okay, so this is like we're finishing Unit 4 and putting everything together. Make sure that when you write your problem that the exponents are in descending order. So you want the highest exponent first. This exponent is going to determine the number of solutions. So at the end, we're going to end up, for this problem, with 4 solutions. Okay, so the first thing we're going to do is we're going to use the remainder theorem. And you do need a highlighter because I want you to highlight the different methods. Okay, so when we're using the remainder theorem, we multiply the first number and the last number. So 4 times negative 27 is negative 108. Then we find the factors of 108. How do we find the factors in the calculator? Do you remember? 108, well, you go to the graph, 108 divided by x, and then you look at your table. I'm going to go ahead and give them to you. So plus or minus 1 times plus or minus 108. Plus or minus 2 times plus or minus 54. Plus or minus 3 times plus or minus 36. Plus or minus 4 times plus or minus 27. Plus or minus 6 times plus or minus 18. Plus or minus 9 times plus or minus 12. Okay, so when you're using the remainder theorem, we're going to be using these factors and start with the smallest and then work down. We want our answer to equal 0. So the first thing we're going to do is we're going to let x equal positive 1. I'm getting the 1 from here. Okay, so what we're going to do is we're going to plug in 1 into our problem. And once we find the answer and the answer is 0, that's one of our answers. That's one of our solutions. So I'm going to plug in 1 wherever I have x. All right, so go ahead and put this in the calculator. And I need everybody to put this in the calculator because some of y'all are struggling or struggle when it comes to those exponents. Okay, and make sure in between here These are minus signs. They're not negatives. So I need everyone to be putting this in the calculator. How are y'all putting it in the calculator if you don't have one at your desk? Jonathan. Okay, so what do we get for our solution? Okay, negative 52. That means this is not one of my answers. So let's try x equals negative 1. Now, inside the parentheses, that is a negative. But in between, these are minus signs.
Teachers, pardon the interruption. With Damilola, please report to the comments. Thank you.
All right, so what do we get for this one? Okay, everybody should have gotten 0. All right, so that is a good thing right there. That means this is one of my 4 solutions. Okay, and as soon as you get 0, then we're going to use synthetic division with that solution. Ready? Okay, so x equals negative 1. So that solution, we're going to use it over here for our synthetic. So I'm going to put negative 1, and then remember we write down the coefficients. So it's going to be 4, negative 8, negative 3, negative 18, negative 27. You bring down your first number, then we multiply. So negative 1 times 4 is negative 4, and then we add negative 12, and then just keep repeating. Our answer at the end, our remainder, needs to equal 0. If it doesn't equal 0, then we have to go back and double check our work. Questions? If you have questions, you need to ask, okay? Yes?
You go down to negative 18. Is it plus or minus? You have negative 27.
So negative 18 and a negative 9
Yeah.
gives me negative 27.
Then you go up and you have a positive 27. Right?
Okay, yes, because I didn't remember it's negative 1 times negative 27. A negative times a negative gives me positive.
Oh, okay.
Okay, that's okay. Okay, so now our next step is grouping. Okay? Now, what is our equation? What exponent do I start off with here? Remember, we go down 1. Okay, so this is going to be x to the third. So it's 4x to the third minus 12x squared plus 9x minus 27 equals 0. Okay, and in grouping, we, like on the board, it was a trinomial. It was 3 pieces, and we multiplied a and c. This is not a trinomial. It has 4 pieces. So it's like it's the next step. So what's the next step after you multiply a and c? What are you supposed to do when you're at this part right here? Group them. Okay, so you group the first 2, you group the last 2. What can I factor out from the first group? And a 4x squared. Okay, 4x squared. And then what do I have left in parentheses? X minus 3. What can I factor out from the second group? A positive 9. So put plus 9. What do I have left? X minus 3. Okay, remember the parentheses have to match. If the parentheses don't match, that means right here, when I write this down, I have to repeat this process. Okay, so grouping's not always going to work. So you would have to start again with the remainder theorem. And we'll do an example like that. Okay, so now they match. What do I do? What do I write? 4x squared plus 9 and x minus 3. Okay, what is my next step? Set them equal to 0. Remember, we're looking for the solutions. We're looking for our roots. All right, so right here I'm going to subtract 9. So I have negative 9 equals 4x squared. Divide by 4. So I have x squared is equal to negative 9 over 4. What's my next step? Square root both sides, okay? When you square root both sides, make sure you remember it's plus or minus. Okay, when you do square root, what do you see that we need to fix? The negative inside the radical. What do I write? So you're going to put plus or minus I, and then when you have a fraction like this, it can actually be separated. And what's the square root of 9? And what's the square root of 4? 2. So then, this is my answer. Plus or minus 3i over 2. So now I found how many solutions right here in this answer? You have 2 of them. You have a positive 3i over 2 and a negative 3i over 2. So now we have a total of 3. Now let's go over here to the right side and then solve for x, and there's our 4th solution. Remember, we were supposed to end up with 4 of them. We know that because of that exponent at the beginning. So when you write your final answer, you're going to write x equals negative 1, comma, 3, comma, and plus or minus 3i over 2. And we're done. Questions? Yes.
So you get your first solution from the remainder theorem?
Yes. Okay. Remember, when you're using the remainder theorem and you get a 0, that's one of my solutions. Okay? And then from there, we jump into synthetic. We have to make sure that this equals 0, because if it doesn't, that means we did something wrong over here. And remember, we need this equation for our next step, for the grouping. Okay? And then that's going to break it down so that we can find our other solutions. Yes?
How do we know what number to like start off with the remainder?
So whenever you find the factors, remember we multiply the first and the last, and that gives us this number. Then you find the factors, and then you're going to work down. You're going to work down. So you do +1 and then -1. +2 and -2 until you get your first 0. You will get a 0. Okay?
So
Yes.
you don't really need the other side.
Well, it depends. I mean, if none of these work, then go this way.
That's crazy.
Yes. So, one problem could take 2 pages. Okay?
So
Yes.
in grouping,
Yes.
where did the plus and minus come from?
When you do square root of both sides, this comes out, the plus or minus.
Even if there's not a negative inside?
Yes. Yes.
Okay.
Yeah. Good questions. All right. We have a total of 3 examples today. And when we have our test, this is going to be your test. This is a test problem. I'm not going to give you one grouping or one synthetic. This is the problem because you're going to put all those things into one.
So one question.
Maybe 1 or 2 questions. Okay?
Are you gonna count it like by parts, or is it like let's say you got the
I know.
and then synthetic, right? But then you got the last one wrong. Does that count the whole thing?
I think you should do that to us. Like at least make like each question like big one since it's like something like that.
We'll see. We'll see what happens. Okay, so at the very beginning, how many solutions? 4. Okay, and it's not always going to be 4. It can be 5. It can be 6. Okay? All right. So, first step is remainder theorem. And I do need you to be neat, okay? Don't crowd your work, because when you crowd it, it's easier to make a mistake. I have paper. I can lend you paper. Yes.
So you said you can probably up to like however big the exponent is. So where will we find all those solutions? Could you find them in the remainder theorem or grouping?
It's all, okay, so like you're going to find your first one in the remainder theorem. And then from there, that's going to lead to your synthetic. And the synthetic will give us our next equation, and then we're going to use grouping. And in grouping, you're going to find more solutions. Okay? And then, like, example 3, you'll be excited with example 3. Okay, we'll see. All right, so first step, remainder theorem. Remember, multiply first and last. So we have a 1 times negative 12. Then we find the factors of negative 12. So it's going to be plus or minus 1 times plus or minus 12. Plus or minus 2 times plus or minus 6. Plus or minus 3 times plus or minus 4. All right, so let's go ahead and start with positive 1. So x equals 1. So we're going to go and plug in 1 for each x. So 1 to the 4th plus... And if 1 doesn't work, try negative 1, and we keep going down the list. And I need y'all to practice putting this in the calculator. I know it's tedious, but we can actually do this by hand with no calculator. Okay? So I need everybody to use the calculator and plug it in. I need you to practice. What's wrong with the calculator? The what? Really? Put it on my desk, please. All right, what do we get? 0. Okay, so we got lucky. All right, that's one of our solutions right there. What's my next step? Synthetic. Okay, so now we're going to use synthetic with our first solution. Okay, so now I'm going to use 1. So 1, write your line, and then your coefficients. 1, 3, -1, 9, -12. Bring down your first number, and then we multiply. And add. Remember,
Just make sure you're getting the one from the
right here. From right here.
oh,
Yeah. So in synthetic, these are all the coefficients. One.
other one.
This
Yeah.
is from here. It's this one. Okay, remember our remainder needs to be 0. It has to match. If it doesn't, then that means we did something wrong up here. We need this part to be correct because that's our next step. All right, what do we do next?
So the remainder always has to be.
It has to be 0. So it needs to be 0. Okay, so next step is what? Grouping. Okay, what is our equation? What exponent do I start off with? X to the third. Okay, remember we go down 1 exponent. So this is going to be x to the third plus 4x squared plus 3x plus 12 equals 0. Okay, what's the next step? Group, okay? So we group the first two, group the last two. What can I factor out from the first group? X squared. So I have x squared. What do I write in parentheses? X plus 4. Second parentheses. What can I factor out? Positive 3, so put plus 3. Then I have x plus 4. Okay? This is what we want. We want them to match. Again, if they don't match, you're going to have to start again with remainder theorem, but with this equation.
Wait, so if it doesn't match,
Okay, so if it doesn't match, all right, pay attention, please. If these parentheses don't match, that means we're going to start over, but with this equation. We would use remainder theorem. So it would be 1 times 12, and we would do this process again. And there's going to be sometimes it doesn't work.
Even though you got 0 at the remainder.
Yes, that's our first solution, okay? So that helped us get here and then here, okay? But if it doesn't work, if this doesn't work, we're going to have to start again. Yes?
At the end of the problem, in that situation, would x equals 1 still be a solution?
Yes, yes. That one is our solution no matter what, okay? All right, so they match. So I have x squared plus 3 times x plus 4. And what's my next step? Set them equal to 0. So I'm going to subtract 3. So I have negative 3 equals x squared. And then what's my next step? Well, if it's a 1, it doesn't really do anything, okay? So you can divide by 1. And then what? Square root. What do we need to remember with square root? Plus or minus. Okay? Am I done? What about that negative? So I need to put my I. So it's plus or minus I. Can I simplify square root of 3? No. So that stays inside. And here's 2 solutions. So now we have 3. Right side, minus 4. So x equals negative 4. So there's our 4th solution. All right, so our final answer is going to be negative 4, positive 1, and plus or minus I square root of 3. All right. Last problem. This one I want you to try on your own. It's the fun, the most fun one.
It's the hard. The last answer was how much 2?
Yes, because it's positive I squared root of 3 and negative I squared root of 3. Okay? Okay. It's so exciting. So let's pretend this is a test problem. All right, did we find our first zero? Okay, don't share it. Yes.
I need some help. Well, I have a question.
Did good for what? Remember, you go down one. So that should be fixed third. Yeah, no, this is your new equation.
Oh, this
yeah.
is the equation.
Yeah. Did we find our first one?
Yeah.
This is a fun one. This is a fun problem. Huh? Oh, yeah. Even students from last year. Remember? Yeah.
So these are like the one-page questions they're talking about?
The what?
Like the question that, like a question that takes an entire page?
This one will take 2.
2? 2?
So when x equals 1, what did y'all get?
Negative.
Negative 12. Okay. So then we try x equals negative 1. What do you get when x equals negative 1? Negative 50? Okay. Which is not good.
Take our test. We meant to like write down all the solutions,
Really?
or you can like guess.
I thought it
Figure
was.
it out.
we can. Do we have
That's what I did on this one. I guess.
You don't admit that. You don't admit that.
No, but like I just guessed one of those things.
You just got lucky.
Yeah.
Well,
I don't know how you did that with 4. I don't know how either. Like, I thought it was right, but I said it wrong.
Right.
No, is it?
Like I counted this big.
yes.
6 squared minus 4x plus 6.
You what?
Do you want to go back for grouping? That's right. We have to go. What you mean?
All right. If we didn't guess, like some of our students, what would be our first 0? Negative 3. Okay? That's our first solution. Negative 3. Okay. Hold on. So from here, I'm going to use, what's my next step? Synthetic. So I'm going to use negative 3. Then I write down all my coefficients. So 1, negative 3, negative 8, 22, negative 24. Bring down your first number, multiply, and repeat. 10, negative 30, negative 8, 24.
So, like, what happens if we didn't use something?
If what?
If we didn't use -3?
If you didn't use negative 3?
I got 132.
No.
Yeah.
You got 132 when you plugged in negative 3? Okay. Then you need to go back and double check it.
I did it twice.
Let me see. Are you sure that you used minus signs right here in the middle? What did you get? I bet you have a negative somewhere instead of a minus.
What happens if we don't?
Keep on going. Put 4 there. And plug it in. You should get 0 here.
Yeah.
I did. As long as my math.
Double check that. It has because if you plugged in 4 and over here you got a 0, then that 4 goes here and this needs to be 0. These have to match.
So it doesn't matter, like, as long as it equals 0.
Yeah?
You should get the same.
Yes. Okay. So. Okay.
So if the starting off problem was
Wait, if we use 4, we
x
just
to
put
the
it like
fifth
that.
power, going down and then going all the way down to grouping, it would be like x to the 4th power.
So right here, you're going to go down 1. So right here, it's going to be x to the 3rd. Remember, with synthetic, your answer starts with
So just like hypothetically a different problem. And the different problem, like example 4 would be like 1x to the 5th power. And
then
that's
this one would be
to the 4th power.
yes, yes.
And so when you get down to grouping, when you group them together, there would be 5 terms.
Exactly, but you cannot use grouping. Because remember, grouping, you have to use, you group 2 and 2.
Yeah.
So that means you have to do synthetic again. I mean, not synthetic. You would have to do remainder theorem again.
So you would have to do it over and
Yes.
over again until you get to like.
Until you get 4 pieces.
Okay.
Okay? Yes.
So when we get to grouping, do I restart it with the new, like,
This is your new one now.
so I restart
Okay.
it?
All right. So the next step after synthetic is grouping. All right. We're not using that first problem anymore. This is our new problem for grouping. And remember, you go down one exponent. So it's going to be x to the third minus 6x squared plus 10x minus 8 equals 0. I grouped the first two, grouped the last two. Yes. Okay.
So like the answers we get for synthetic division should be the same for me?
No,
Or, oh,
because you used 4. Okay. So, what can I factor out from the first group?
X squared.
X squared. So then I have x minus 6. What can I factor out from the second group?
2.
Positive 2. And then I have 5x minus 4. What happened? They're not matching. So we have to start over again. Okay? We're going to start over again, but now this is our equation. Don't start over with this equation. We have to start the process again. Okay? So this is where, so what I'm going to do is I'm going to draw a line here. We're still in the same problem, but now this is my starting point. So it's going to be x to the third minus 6x squared plus 10x, plus 10x minus 8 equals 0. This is one of those special problems. Okay. Remainder theorem. All right, so I multiply 1 times negative 8, and then I find the factors of negative 8, which are plus or minus 1, plus or minus 8, plus or minus 2, plus or minus 4. Okay, so it is less factors. So start with x equals 1 and plug it in. This is probably the hardest part of Algebra 2.
You're not sure?
Hmm?
You're not sure? Probably.
That this? What?
This is the hardest.
No, it is. Yeah.
Is it hard or is it just time consuming?
It's just time consuming. Like the rest of the stuff that we're going to cover for the year is graphing and like we're here. These are similar to the absolute value stuff that we did before, where you give me like it shifts to the left 3, down 4, and all that stuff. The transformations. All right, so what did we get when we plugged in 1? Negative 3, which is not good.
We have a test next week?
Yeah. X equals negative 1. Yes.
Open notes test.
you agree with
What do we get when x equals negative 1?
25.
Negative 25. Keep on going. X equals positive 2.
I'm not writing it down.
You need to write it down, Isad.
I've been writing it
No, he hasn't. I can see. I'm watching you. You're just pressing buttons.
It's like a video game.
Mm-hmm. Okay, so when we plug in 2, what do we get? -4. Still not the one. X equals -2.
I got it.
Shh. So what do we get when we plug in -2? -60. That doesn't work. So now let's try x equals +4. There's our 0. This right here is my second solution. Okay? What's after remainder theorem? Synthetic. So we're going to use this +4 for the synthetic. Okay, so are we done? I'm going to turn the page. So I'm going to use +4 for my synthetic. Okay. So +4, and remember, this is our, we started over here, okay? This is our equation that we're going to use for synthetic. So 1, -6, 10, -6. Bring down your first number. Multiply, yes.
I remember that when we did synthetic addition, we would get like 4 equal to like x equals.
Yes.
We don't do that.
Well, we already did it. Yes, yes. And again, last number should equal 0. So now, this is our equation. Okay, what exponent does this one start with? X squared. Okay, remember you go down 1. So, what's my next step after synthetic? Grouping. So it's going to be x squared minus 2x plus 2 equals 0. All right. Grouping, I multiply first and last. That gives me +2. Factors of +2 are plus or minus 1 times plus or minus 2. Are there factors of 2, and it's positive, are there factors of 2 that add to -2? So what do we need to do when it doesn't work?
Or we give up.
No, we use the wonderful quadratic formula. Yay! Yes.
Quadratic formula better.
Could you just use it if it didn't work?
I love the quadratic formula.
No, because it has to be a trinomial. For quadratic, quadratic is squared. Okay? All right, so
Quadratic formula.
So our equation is x squared minus 2x plus 2 equals 0. Yes?
If you were to continue with like the remainder again, would you get the same answer?
It won't work.
It won't work.
It won't work. Okay, so this is my A, my B, and my C. And remember I told you to set it up first because we tend to make mistakes with this quadratic formula. So set it up with your parentheses and then plug in. So oops. Okay, and again, in your calculator, just do the inside of the radical. Okay, what do I get inside the radical?
I don't know.
Did you put this part in the,
Yeah, but like it gave me the answer like it gave me 2.
okay, no radical.
It gave me like 2i.
No radical. Don't use the radical. Okay, just the inside. Okay, so it gives you -4. All right. There's my negative radical that I don't want.
Oh, we don't use the negative.
So 2 plus or minus. What do I write? I. So that means that negative goes away. And what's the square root of 4? So that 2 comes outside. Over 2. Okay. So did you get -4 right here?
Yes.
Okay. So for that negative, I'm going to write my I. So that negative goes away, and I'm left with square root of 4. And the square root of 4 is 2
Oh, we missed it.
Where'd you get the other side?
from here.
So we don't do anything with that?
Huh?
We don't do anything.
Okay. We go ahead and multiply it. Bring it right here. And then this gives me my plus or minus 2i, and then this is 2 times 1. Can I go further? Okay, remember I told you that if these numbers outside of the radical are divisible by a number, you need to divide it. Okay, so we're going to divide each of them by 2, so this becomes a 1, 1, and 1. Do I need to write the 1 in the denominator? No. So then I'm going to have 1 plus or minus. Do I need to write the 1 next to the I?
No.
You don't have to. Okay? You don't have to, but you can. But this one right here, this one, it has to be there. This one does have to be there. All right, so right here, this is our third and fourth solution. 1 plus 1i and 1 minus 1i. Okay, so the negative, there's your I. So that negative goes away. So now you have square root of 4. What's the square root of 4? 2.
Oh, okay.
Okay? Okay, so our final answer is the very first one we got was -3. Then we got 4, and then 1 plus or minus I, or 1i. Isn't that fun?
Yes.
Yes, of course.
If we were to use the 4, would it be like the other way around? Would it be 4 and then -3?
Either way.
Either way?
Either way. Okay. Yes.
When you simplify like all the twos into ones, why don't you write the divided by 1 on the bottom?
You can. You don't have to, but you can. Okay. So now I'm going to show you the shortcut. Okay. But the reason I didn't show you the shortcut first.
Because you wanted us to learn.
Yes, that's part of my job right there. Yes. Okay. And because I need you to take care of these calculators. Okay? I started with 30, Marissa. And I have 3 not working already. Okay? B's need to be taken care of. We can do this whole problem without a calculator. Yes, we can. We can do the whole problem without a calculator. So this is a privilege. We need to take care of it. Okay? Now, go to your calculator and go to graph and delete what's there. Okay? Go ahead and put the original problem in there. So, right here where it says example 3, put that whole problem in there. Pay attention, please.
Like exactly what equals 0.
No.
Don't put equals 0 in there. What's wrong? Oh.
Thank you.
Mhm. Okay, so we put the original problem in there, so it's going to be x to the 4th minus 3x. Graph it.
Figure it out.
Okay, this is what we should end up with when we put the original problem from example 3 in there. Okay. Where does it touch the x-axis? Pay attention, please.
4 and negative 3.
Negative 3, which was one of our answers, and positive 4, which is another one of our answers. Okay? So, if we're allowed to use them, the calculators, we can already graph it and find 2 answers. Then we have to find the rest of them. All right? So, get a sheet of paper out, and I'm going to show you how to use the shortcut. This is your assignment. This is a problem that you're going to do and turn in. Quickly, guys, because we're running out of time. Hurry, got 3 minutes. 3 minutes. This is the problem. Write down this problem.
Can we graph it or no?
Yes. We're going to use shortcut. So go ahead and put it in the calculator right now. Okay, when we put it in the calculator, where does it cross the x-axis?
2 and 3.
At 2 and 3? Okay. We have 2 solutions already. How many are we supposed to end up with? 4. Okay, so go ahead and write x equals 2, comma 3. We are jumping, we're not going to do remainder theorem because we already found the answers. So the next step is synthetic. So you're going to use synthetic with 2. Okay? With 2. So you're going to use synthetic with 2, your answer that you got from the graph. Okay? So pay attention because I need you. We're running out of time. The bell's going to ring already. So you use 2. You do synthetic, you end up with an equation. Write down that equation, and then you're going to use 3 and do synthetic again.
We're using the 2 solutions we got from the graph and doing synthetic division with both.
Yes. Yes. Okay, so you have 2 solutions. It was 2 and 3. So let's use 2, and then we're going to do the synthetic 2 line, and then you write your coefficients. You work it out. Remember, it has to end up with a 0 at the end because that was their solution. You get an equation, That equation, you write it down, and then you use your next solution, which was 3. And then you do synthetic. You can do that without a calculator. You don't need the calculator. All right. Y'all have a good day. Yes.